Welcome to today's webinar, Implementing Microsoft DirectAccess and NAT in the AWS Cloud. Our presenter is Scott Roberts. Scott is the Principal Product Manager of EC2 for Microsoft Windows Server. He has a long track record of shipping highly innovative information technology and software security products and services. Prior to AWS, Scott spent more than 12 years at Microsoft, first in trustworthy computing on the Microsoft Security Response Center team, where he was co-creator of Patch Tuesday update process, as well as secure development lifestyle practices. Later, he was responsible for shipping features across Windows Client and Server, Xbox, iOS, and Android platforms.
Hello, thank you for having me. I feel privileged to have the opportunity to talk today about Microsoft DirectAccess and Windows NAT in the cloud. I believe that these are very compelling scenarios for AWS, and I look forward to explaining how we're able to deploy that inside of AWS. In this presentation, what we're going to cover are two main topics. We'll start by discussing how to use Windows Server 2012 R2 as a network address translation device, and we'll also show how that can be used in combination with the Microsoft DirectAccess Windows Server role. We will be leveraging multiple tools and technologies from AWS, including the AWS Toolkit for Microsoft Visual Studio and the AWS Toolkit for Windows PowerShell. We're going to leverage these tools in order to see how to fully automate these deployments, and we'll be able to look at some tips and tricks as well for further automating and simplifying the solution. We'll be leveraging CloudFormation templates so that you can easily modify these scripts and customize them for your own solution. This presentation will give a broad overview of the details that are disclosed inside of the white paper, and the URL link is available. But we won't go step by step. This is more trying to give a high-level overview and demonstrate the power of using the AWS Cloud for these technologies. We'll start with a broad overview of the server roles that are involved in the architecture. We'll then walk through the architecture elements step by step. We'll show you how to do the deployment and then post-configuration steps. The image that's shown on the right demonstrates the end-to-end solution. We'll be looking at configuring multiple server roles and automating them through CloudFormation and Windows PowerShell. We're going to break this presentation into 4 key parts. We'll do an overview of the server roles so that we can build the entire image that you see there. We'll blow this up into more detail later. We'll walk through the architecture step by step and show you how to deploy this, as well as things that you can do once you have it deployed. Starting with the server roles, we'll describe kind of piece by piece what is provided here. Network address translation, as many of you may know, provides a method of converting one IP range to another IP range. This is often used on the edge of our networks in order to shield the private address space used on the inside of the network from the public IP address space used on the outside of the network. One thing that I noticed when I started working with the EC2 Windows product team was that many of our enterprise architecture CloudFormation templates still utilized a Linux NAT role, even though all of the other server roles were using Windows. We also had a number of customers inquire about using the Windows NAT role to replace the Linux NAT device. And so this is able to demonstrate how you can achieve a functioning NAT role using Windows, and we'll show you the pros and cons of that solution. We also want to demonstrate additional server roles such as DirectAccess. We have today solutions for Exchange, SharePoint, and SQL, but not DirectAccess. So this fills that gap for us. DirectAccess, if you're not familiar with it, allows for seamless connectivity across the internet between 2 endpoints without the need for a traditional virtual private network. So as long as the resources that have DirectAccess enabled are connected to the internet, they can connect to the corporate network. More information for DirectAccess is listed at the available link. DirectAccess has multiple topologies, and in essence multiple ways that it could be configured. And what we're going to be looking at is the DirectAccess setup that is what's called a single network interface behind a NAT scenario. DirectAccess has multiple other scenarios, but this is the easiest to demonstrate. One caveat for what you're going to see is that this is designed for technical demonstration purposes. The white paper and these scripts build a test lab for educational purposes that match closely the existing Microsoft Test Lab guides for DirectAccess. So this is, for example, why we've used a NAT device instead of directly connecting the DirectAccess server to the internet. But it is totally possible to do that. It is also possible to combine DirectAccess with other AWS services such as Elastic Load Balancing, combined with Microsoft's Windows Network Load Balancing for creating production scale global geo-aware high availability solutions. I'm working on an additional guide that goes through those details. But to start with, we wanted a very simple lab guide for demonstration purposes. The topology we're using of a single network interface controller behind a NAT for DirectAccess also means that within DirectAccess, certain technologies are used to transport the connection over the internet. When we look at the pieces of the solution that are required to put this together, the first one we start with is the AWS CloudFormation. CloudFormation provides a way to automatically create a set of resources that you need to run your environment. It will help us automate the creation of our virtual private network, all of our DNS modifications, all of our instance creation. All of the configuration required is able to be completely automated using our CloudFormation templates. Some of the feedback from customers has been using CloudFormation templates can be very beneficial, but there are some things I'd like to see improved, such as the ability to pass information between CloudFormation templates, as well as ways to make it easier to specify things like the OMI IDs within the CloudFormation templates. And I show you some tips and tricks in this presentation that I use to help make this easier. The foundation of our environment is our Amazon Virtual Private Cloud, the Amazon VPC. For production environments, we always recommend creating multiple availability zones. That way you have redundancy and availability across the resources. Again, though, this is a test lab guide, and we just use one availability zone for demonstration purposes. It is possible to connect this demonstration lab guide with traditional VPN through Direct Connect or over the internet back to your on-premise network, where you're able to then leverage an AWS-hosted DirectAccess server to provide seamless connectivity back to your on-prem network. This is an enlarged view of the network that we're going to build through CloudFormation. We'll walk through each piece of this and show you how it's constructed. At a high level, what you'll see are two VPCs. One VPC on the right is our equivalent of our corporate network. It has both a public subnet and a private subnet, and our Windows NAT server is sitting in between our public subnet and our private subnet. So we'll be able to demonstrate how we pass the traffic through our Windows NAT device. Connected over the internet in a separate VPC is another subnet. In this case, we're referring to this as our Windows client network. And in this case, our Windows clients that we're going to be referring to are Windows Server 2012 R2, used as a demonstration client for this purpose. The interesting part about this solution is that we build it on the live internet using and automatically provision the entries inside of Route 53 so that you can actually seamlessly connect from one VPC through to another VPC over the public internet. Let's take a look at this piece by piece, starting with the NAT configuration. In this case, you're going to have a Windows EC2 Windows instance that has two ENIs, or network adapters, with each network adapter attached to a separate subnet. So in this picture, you see ENI 0 connected to our public subnet and ENI 1 connected to our private subnet. This then creates a pathway to flow the communication through our NAT device. Security is also enforced through our subnet configuration inside of the AWS environment, as well as the route entries. Now, there are some configuration difficulties that customers have had when performing this configuration. By default, when you configure your EC2 instance, inside of the instance, it has configuration performed through DHCP. So although you statically can configure the IP addresses in your CloudFormation templates, inside of the Windows instance, it still feels as though it's been configured using DHCP. When you have multiple network adapters that are configured using DHCP, this will create a routing table configuration issue inside of the instance, as it also specifies a default gateway associated with each of those networks. So what ends up happening is packets flow into the instance. There's ambiguity as to which interface the packet should flow back out of. There are multiple ways to solve this through creating custom route table entries. But in this case, I preferred to use a simple solution, which was simply removing the DHCP setting from the private subnet connected interface, and within the instance, statically configure the IP address. This has the benefit of removing the redundant default gateway entry inside of the instance and ensuring the traffic flows smoothly. The downside of this approach is that if you ever decide to change the IP address using the AWS console, that you would also have to manually configure the address within the instance as well. Once we have our two subnets created and we have connectivity between the subnets, the next piece of the deployment we enable is the Windows domain controller. In this case, our Windows domain controller is going to be connected to only the private subnet. So this means that any connectivity that you see to the domain controller will have happened through our Windows NAT device and then through our DirectAccess server, which is going to be shown in the next diagram. In addition to the standard Active Directory domain controller configuration that you've seen potentially in other CloudFormation templates, this test lab guide enhances those templates by also adding the certificate services role to the DirectAccess to the Windows domain controller. This enables us to provision our SSL certificates and IPsec certificates used to secure the environment. We also configure a web server and a default web page on the web server. I find this to be very helpful in troubleshooting connectivity, ensuring I have end-to-end connectivity flow by hitting a web resource. Again, this is for test lab purposes. One of the other issues that you have to overcome inside of the CloudFormation template is that it often runs underneath the security context of a local system account. When you're configuring certificate services, it requires you to be actually logged in as a domain administrator account. Inside of the scripts, I show a way to create a scheduled task and run these steps as an elevated user account. The next piece of the configuration is our DirectAccess server itself. So you'll see it in the bottom right-hand corner of the screen. We call it Edge 1 in this particular case. The connectivity flow is going to occur through the Windows NAT device, through to the DirectAccess server, and then from the DirectAccess server to the local private subnet. For those of you that know about DirectAccess, you might have heard that it leverages TCP/IP v6. But we don't actually flow the TCP/IP v6 packet through inside of the private or public networks. The way we handle that communication is through a series of DirectAccess mechanisms that takes the v6 packet, places it inside of a v4 packet to transit it over the public internet. When the DirectAccess server itself receives the packet, it retrieves the v6 packet from within the v4 packet, and it uses a technology called a NAT 6.4 to convert that packet to a v4 packet, and then uses TCP/IP v4 on the private subnet. So the only place that we actually have to enable TCP/IP v6 is on the DirectAccess server itself. As we're configuring the DirectAccess server, we'll also use the certificate server on the domain controller to provision our certificates. And we also use a technology called an offline domain join. One of the configuration challenges with DirectAccess is that it has to be seeded with information about the DirectAccess server and certificates in order to connect successfully. In Server 2012, Microsoft created an offline domain join technology that allows you to export that information into a configuration file, import that information into a remote machine so that it is able to bootstrap the connectivity process to the network. In this case, we'll be sharing the offline domain join file over our public internet connection for testing purposes. In a production environment, you'd want to make sure that you pass the offline domain join information in a secure manner to the client. We'll also configure our Route 53 domain with our external IP address. And the final piece is our second virtual private network, which is connected over a separate internet gateway to the internet. We'll load the offline domain join file onto our remote machine, and then it will seamlessly have connectivity through the NAT device, through the DirectAccess server Edge 1, onto the domain controller. So in a single provisioning capability, you'll be able to log in locally to the client machine using domain credentials. So if that sounds interesting, let's show you how we're going to actually achieve that. As I mentioned before, we use the AWS Toolkit for Visual Studio. You can use this to edit CloudFormation templates. I'm not going to demonstrate the CloudFormation templates, but I will demonstrate the AWS PowerShell through the AWS Toolkit for Windows PowerShell that we use to actually automate the deployment. The first step, and this is outlined in more detail inside of the white paper, is to download the initial provisioning script. So this is the URL where the script is currently located. And since this is designed as a test lab and for educational purposes, I actually require you to edit the scripts. So what you'll first do is launch our command called prepda. This downloads additional helper files, such as our buildda server1nic.ps1 file, and you'll edit this file with your configuration, including your specific domain name that you previously need to have configured inside of Route 53 and the key pair for your environment. Once you have done that, then by simply launching this one command, it will build all 4 of those server roles that you saw and all the associated AWS infrastructure resources that are required to enable that configuration. When you launch the command, it will take each piece of that architecture that I showed and build it step by step. What we've done here is actually created 4 separate CloudFormation stacks, and we build them one at a time. So instead of having one CloudFormation template that builds all 4 of those pieces, I've broken that up into 4 separate CloudFormation stacks. We will start by using Windows PowerShell to launch the creation of our Windows NAT stack. The scripts will loop until the Windows NAT stack is complete. It will then query information, such as the IP address information, the subnet IDs that are generated. It will extract that information from that stack and then pass that to the second piece of the architecture that I showed, for example. The next part would be creating the domain controller, then the Edge 1 server, and then the client role. So it cycles through all 4 of these stacks, passing the data from one to the next. Once it's complete, inside of your AWS console, you'll see the 4 servers listed, Client 1, DC 1, Edge 1, and NAT 1, and the external public IP addresses associated with those things. So instead of just talking about it, let's actually take a look at what that looks like. I have a demo environment that I've connected to. Okay. And we'll start by taking a look at the actual script. So after you run the prepda script, it downloads a buildda server1nic.ps1 script. The key elements that you have to edit are going to be your domain name, your root domain, a subdomain, and then the name of the actual server that you want to connect to. So for example, this is my wife's name, and I bought a domain name based off my wife's name to use for just testing purposes. So I own serena.org, and I've hosted that inside of Route 53. I've created a subdomain for that called corp, and the actual name of the DirectAccess server in this case is going to be DA for short. I've also configured a name of a key pair that is available to the account that I'm using to launch the script. And that is really the only modifications that you need. You can further automate that as input parameters. I decided to leave this as something that you have to edit in order to make sure that you are using this for its full educational value. Now, I do want to show some additional tips inside of the script. As you scroll down further, you'll see 4 templates. These represent the 4 stacks that we're going to build. So you can download each of these templates and load them inside of the Visual Studio, a CloudFormation editor, in order to further configure them. I set the IP addresses and the instance types, for example, here. So if you wanted smaller or larger instance types or to change the names of the stacks, it's fully configurable. One of the other interesting elements about the script relates to how I achieve the actual Windows Server AMIs. As you know, every month we ship new Windows AMIs after the completion of the Patch Tuesday cycle, and the AMI IDs change. This creates a pain point for a lot of template authors, where they normally have to hard code in the AMI IDs inside of the template. By using PowerShell combined with CloudFormation, you can dynamically query, which is what I'm showing here, for the current AMI IDs for Server 2012, pass those into a variable, and then when you launch the template, you can pass that AMI ID in as a parameter. This allows you the scripts to work every month without modification. The next step is to take the values that I've mentioned, such as the key pair, the AMI ID, as I mentioned a moment ago, and the type of instance, and I actually pass those as values into a function that launches that stack and monitors the stack for completion. So I called it build values. And what then will happen is from the output of that Windows NAT stack, we'll have a series of values that are returned, such as the subnet ID, and then those values are then passed as we then build the next stack. So we'll build the domain controller, we'll build the DirectAccess server, and then we'll build the client stack. So in this way, you can see we've built the network in a very modular way. The nice part about this is that it would allow you to roll back, for example, and delete the domain controller, the client, and the DirectAccess stacks without having to rebuild the NAT stack, for example. I will go ahead and demonstrate the execution of this, but it does take a little while to build, so that later demonstrations will be based off of a pre-built network. If I look at my AWS console in the CloudFormation section, I can see at the moment I have no CloudFormation stacks that are created here. What I will then do is then launch the script, and this is a modified version focused on the West 1 region. I get an initial warning screen that this is going to create resources, and there's real fees associated with those resources, and make sure that you've edited the configuration, and then we'll launch the configuration. So it's initiated the creation of the Windows NAT stack, and then the script goes into a monitoring phase, and it loops for every 60 seconds. You can press enter to accelerate that to see if the stack has been created successfully. And once it's been created successfully, it will then take those values and pass those to the next stack. If I go back to CloudFormation and refresh my view, I can see that the Windows NAT stack has started to build. I can highlight that stack, and I can see what step in the building process has been achieved. So for example, at this point I can see it's initiated the creation of our internet gateway and launched the creation of the resources. So this process will take a while. If you have any issues as you're launching your stacks, this is where you would come to view any sort of errors that might occur for troubleshooting purposes. When this is complete, it should look something along these lines here. So as the script completes each of the stacks, it'll then launch the next stack, and you can see the completion all the way at the end of the client 1 stack. The instances upon completion will look like this. That's the first part of how we actually built the environment and what the script execution process looks like. The last piece of the environment, the last piece of the presentation, is to look at our post-configuration steps. How do you know it has actually worked properly? Once the deployment has completed, what you will be able to do is use remote desktop and access the client using the domain credentials. Now this is interesting to consider because the client 1 resource is sitting in its own VPC. The domain controller is not local to that client. There's no VPN that's been configured between that VPC and other VPCs. The client machine will be connecting over the internet through our NAT, through the DirectAccess server to the domain controller for connectivity. You can also access the web URL for the web server we've created in the domain controller to prove the end-to-end connectivity. Standard commands such as ping or the newer test net connection are able to be used to verify that connection. So let's take a look at what that experience is like. So normally, inside of the console, you would use the connect option, and you would download the remote desktop file, and you have the IP address of the server. In this case, it's 54.149.238.110. So I've opened up a remote desktop connection here, where we can type this in. In this case, we're going to use our corp/stack admin account. Now, this works even on the first access to the client. You do not have to use the locally generated administrative account with the randomized password that's used. We can use our domain credentials here upon first access, because the offline domain join file has been applied to the client machine and it's already been restarted in order for it to be complete. So here you can see I've accessed this client machine, I've used domain credentials, and I've seamlessly been able to log in. I also can view resources. So for example, the web page for the domain controller. I create just a simple domain controller page with what my IP address is and what the server IP address is. So you can see the connectivity flowing through to the network. You can also do various command line tests, as I showed before, such as I'll do a testnet connection to our dc1.corp.serena.org. That's the new version of ping. You also can see that all of your file share connectivity or NetBIOS connectivity is working as well. So commands such as netview over the DirectAccess connection will work. So I can see the default shares on the domain controller. And you can see the v6 addresses that are actually being used in this process. So the remote v6 address and the client's source v6 address. But these are all transiting over v4 only connections through a combination of DirectAccess's v6 over v4 transition technology and the NAT 6.4 that's operating on the backside of the domain controller. You also could view these resources inside of File Explorer. So we have seamless and bidirectional connectivity between a remote machine in a dedicated VPC through to our domain controller. And the fact that it's bidirectional is very interesting. So for example, coming from the other direction, this is a two-way connection. So coming from the corporate network or a network you've connected to the corporate network, you would have full remote connectivity to this client machine over the DirectAccess connection itself. So in this demonstration, we were able to build our simulated corporate network with a DMZ. A Windows NAT server was able to sit connected in a dual home way between our public network and our private network, routing the connectivity through to our DirectAccess server. It also functioned as a remote gateway device. So if you needed to RDP into the private network, you can RDP to the NAT1 device. The NAT device was forwarding ports 80 and 443 to the DirectAccess server. Those are the only ports that it had opened. We set up our domain controller with certificate services in order to support our IPsec and SSL connections. We also built the DirectAccess server using a single network adapter. And we were able to show dual two-way connectivity from a remote network to our simulated corporate network. And the initial bootstrapping was performed using the Windows Offline Domain Join file. There are a ton of resources, as we called out, that are linked and that we build upon in order to use this solution, from CloudFormation to the Visual Studio toolkits to the PowerShell toolkits, as well as building on top of the Active Directory reference guides and other reference guides that are available. That I've listed those resources here for reference. So at this point, we'll go ahead and transition to question and answer, and I appreciate the time.